Hyperbola with center not at the origin. In the previous videos, we discussed hyperbola with center at the origin. Now, we are going to discuss hyperbola with center not at the origin.
The equation of a horizontal hyperbola with center at the origin is x squared over a squared minus y squared over b squared equals 1. For hyperbola with center not at the origin but at point h, k, we have quantity x minus h squared over a squared minus quantity y minus k squared over b squared equals 1. Here is a Cartesian plane with point h, k.
Since our hyperbola is a horizontal hyperbola, so our transverse axis is parallel to the x-axis passing the point hk. So our transverse axis must be the horizontal line with the equation y equals k.
Perpendicular to the transverse axis at point h, k must be our conjugate axis, so our conjugate axis is the vertical line with the equation x equals h.
From the center at point h, k to the right and to the left with distance a are vertices, so it must have the coordinates h minus a, k, and h plus a, k. For the foci, from the center h, k with distance c to the left and to the right are the two foci with coordinates h minus c, k, and h plus c, k.
With distance b from vertices are the two asymptotes passing.
The first asymptote has the equation y minus k equals p over a times quantity x minus h, and the second asymptote has equation y minus k equals negative b over a times quantity x minus h.
The equations are the point-slope form that pass the point h, k with slope b over a.
Let's sketch now the hyperbola from the two vertices and the asymptote lines as guides to the opening of the hyperbola. This is a horizontal hyperbola with center at point h, k with y equals k as transverse axis, and x equals h as conjugate axis. Example: sketch the hyperbola quantity x minus 1 squared over 9 minus quantity y minus 2 squared over 16 equals 1.
From the equation, we have a squared equals 9 and b equals 16.
Getting the square root, we have a equals plus and minus 3 and b equals plus and minus 4.
We have also c squared equals a squared plus b squared.
So c squared equals 9 plus 16, so c squared equals 25. Getting the square root, c equals plus and minus 5.
So the center h, k is 1, 2.
The first vertex of the two vertices v sub 1 point h minus a, k is 1 minus 3, so v sub 1 is negative 2, 2. And v sub 2 h plus a, k, so v sub 2 is 1 plus 3, so v sub 2 is 4, 2.
First of the two foci has the coordinates h minus c, k, so f sub 1 is 1 minus 5. So f sub 1 is negative 4, 2. F sub 2, the second foci, has the coordinates h plus c, k, so f sub 2 is 1 plus 5, so f sub 2 has the coordinates 6, 2.
Now, using the derived values of b, let's solve for the asymptotes. The first is y minus h equals b over a times quantity x minus h.
Substitute the values. We have y minus 2 equals 4 over 3 times quantity x minus 1.
Transpose 3 to the left side by multiplying it to y minus 2.
Distribute 3 and 4, so 3y minus 6 equals 4x minus 4.
Transpose 6 to the right, so 3y equals 4x minus 4 plus 6, so 3y equals 4x plus 2.
This is the first asymptote.
The second asymptote has the equation y minus k equals negative b over a times quantity x minus h.
So substitute the values. So y minus 2 equals negative 4 over 3 times quantity x minus 1. Transpose 3 to the left by multiplying it to y minus 2.
Distribute 3 and negative 4, so 3y minus 6 equals negative 4x plus 4.
Transpose 6 to the right, so 3y equals negative 4x plus 4 plus 6, so 3y equals negative 4x plus 10.
This is the second asymptote.
Here is the Cartesian plane, and let us plot the points. First the center 1, 2.
Next the two vertices negative 2, 2, and 4, 2.
Then the two foci negative 4, 2, and 6, 2.
Connecting these points, we have the transverse axis y equals 2.
Perpendicular to the transverse axis at the center stands the conjugate axis with equation x equals 1.
Next is the first asymptote with the equation 3y equals 4x plus 2.
And the second asymptote line with the equation 3y equals negative 4x plus 10.
From the vertices with asymptote lines as guide to the opening, let's sketch now the hyperbola. This is the hyperbola quantity x minus 1 squared over 9 minus quantity y minus 2 squared over 16 equals 1.